Welcome to this tutorial. I'm Thomas Weibenfarter, developer from Sweden, and I'm back again here on freeCodeCamp to show you how to build a cool little Arkanoid game in TypeScript, plain vanilla TypeScript. And as usual, I love to create videos for freeCodeCamp. FreeCodeCamp is great, so that's why I have provided this video for you. And if you don't already know it, I have my own YouTube channel that you can visit for weekly videos on stuff like this. I do a lot of React, Gatsby stuff, and also a lot of other JavaScript stuff and HTML, CSS, you name it. And I also have more premium courses that I have on my site. So all the links for this is down below. And please support me and visit my channel and subscribe to it if you like my stuff and teaching style. So nothing more to say here. Let's get started. We're going to build a classic Arkanoid game, or I think it's called Crackout or something also. I don't know. But for me, it's Arkanoid. I had a Commodore 64 when I was young and also an Amiga. So it was called Arkanoid. So this is some kind of clone of that game that I'm going to show you how to build with vanilla TypeScript. No React or stuff like that. Just plain TypeScript. But I'm going to use Parcel to make it a little bit easier for us to create modules and different classes and stuff. And the game looks something like this. You have this paddle and a ball that bounces, and you can see that these bricks have different energy set to them, so you have to hit them more times depending on what color it is. I think the ones at the top is going to have just one energy level, and the purple, blue, and yellow are going to have, I think the yellow one have two, and the blue and purple may have three or something. Yeah. So this is the game that we're going to build, and it's going to be super fun. I'm going to create classes and stuff like that. I'm not going to go all in on object-oriented programming, as JavaScript and TypeScript isn't meant to be a fully object-oriented language. But I'm going to show you some neat stuff in TypeScript and hopefully give you some idea on how you can build a game like this. So let's continue on. I'm going to talk a little about the starter files that I provided for this tutorial. All right, we're going to start to build this game. And the first thing I want you to do is to go inside of the starter files that you hopefully downloaded. And there's a folder inside of there that's called something like Arkanoid TS start here. Navigate inside of that folder, run npm install, and then you type in npm start, and that will start up your dev environment. So this is how it will look. This won't work now, of course, but if you check your console, it should console log out start here. And that's the starter files for this course. And I'm going to go through the starter files right now. So go back to your code editor, and you can see that I'm inside a folder here that's called Arkanoid.ts. As I said, yours is going to be called dash start here. If you don't rename it, you can, of course, rename it to whatever you want. So what we have here is the tsconfig file, and this is a basic one. I haven't made any changes to this one because you can set up TypeScript with the different rules, and it's very, very subjective on how you want it. So I want to keep this to a minimum. And we're using Parcel for this course as a bundler. So it will have some default configs. So you don't even need to have this tsconfig. But in this case, I needed it because I'm going to import some images and stuff. So that's why I have it. Then we have the package.json. And you can see here some different stuff here that I set up. I set up ESLint with TypeScript. And I have Parcel. And I have Prettier and TypeScript installed for this ones. So that's what I set up in the starter files for us. So it's essentially a Parcel setup where I set up TypeScript and Prettier and also set up the linting stuff here for us. All right, so that's the package.json. Then inside of the disk, there's where our application is going to go when it builds. Then we have the src folder, and that's the folder that we're going to be working in. So we have some different stuff here inside of the src folder. We have an image folder with all the bricks, the ball, and also the paddle should be here, yeah. And then I have an index.ts file, and this is because I want to be able to import these images. So I have to declare these PNG images and specify type for them. Otherwise, we can't import them as a module. And it's very convenient to import them as a module. Then we have the index.html file. So this is the index.html file that Parcel will use when we build our application. And you can see here that I created a canvas. I also have a background. That background is positioned below the canvas. So the canvas is transparent and this image is shown below that canvas. So that's why we can see that star background. Then I have a div with the display and the start button and some info if it's game over or what's happening. And then the script tag that will import a script. And I created some basic styles for us. So this is in no way a finished game, so to say. The main purpose with this tutorial is to get some solid TypeScript practice. So there's a lot of stuff you can do with this game if you want to expand it and add in functionality and also restyle it and make it even more beautiful. All right, then we have the index.ts file, and this is the main file. You could also create a class for it if you want and call it something like game class or something. I don't know. I'm going to have the main stuff for the game inside of here. And we're going to create classes for the bricks, for the paddle and for the ball, and also a class for the view. So we're going to add that stuff in here. Then I have a setup.ts file. And here you can see that I'm importing my images, and that's why I needed that little type declaration here so that I can import the images like this. Then I grab the canvas and I'm going to set up some stuff for us here. We're going to set the stage padding, stage row, columns, brick padding, brick width. And you can see that I calculate the brick width and height depending on the size of the canvas. So that's what I'm doing here. And we can set the paddle width, height, start, X, speed. Yeah, a lot of stuff that you can just change here and it will hopefully work when you change these values. Then I have a lookup object for my brick images. So I import them here and then I place them in this lookup object with different keys here, 1 to 5. And that means that I can create my level here. So if, for example, I have the number 2 here, it will grab the green brick. And this is from top to bottom. So we don't have to care about the blank space below the bricks. So we start from top and then we draw our bricks. We're going to have 5 of them. And I also assign different kind of energy levels to these bricks. So for example, the purple brick, you're going to have to hit them 3 times before it disappears. And we're going to see this in action later in the course. So that's the setup. Then I set up some basic types. That's the shared type for the vector, the X and Y position. Maybe overkill to have a separate file when there's only this that is shared. So yeah, but it's always good to have a file where you can put your shared types and you can import them because you can see that I'm exported here. So you can import this type to any file where you want to use it. All right, so that's the starter files. Let's continue on and create the canvas view. Make sure that you started up your dev environment and you have everything in place. You are using the starter files and you have run npm install. And to run the dev environment, you type in npm start and you will be good to go. We're going to start creating a class that we're going to call view. So inside the src folder, create the new folder that we call view. Like this. And inside of that one, we create a new file that we call canvas view, capital C, capital V, .ts. And it's going to work like this. Then I'm going to create a view class for us to use because now we're going to draw on the canvas. So I'm going to create a specific class that will be able to draw on the canvas. And this is because let's say that you don't have a canvas and you want to draw your game in another way, then you can create a specific class, and as long as it has the same interface, the same methods to call, you can always swap this class out. So that's why it's good to keep it in modules like this. And I will also say that TypeScript and JavaScript is not really a true object-oriented language. So that's why I'm not going to go all in on classes. I'm going to use classes for most of the part. But for example, as I told you before, the index.ts is not going to be a class. I'm going to create the code directly inside of that file and don't create the game class. So it's going to be a combination of classes and regular JavaScript files in this one. All right, so we're going to create our class. And actually, this view class is also going to need the brick, paddle, and ball class. So we're going to scaffold these ones out, and we're going to come back to those classes and finish them later. So inside src folder, create a new folder that we call sprites. I call them sprites. Create a new file, ball.ts, and another file that's called paddle.ts, and a third file that's called brick.ts. And inside of these classes, we can just scaffold them out. And for all of these classes, we're going to need that vector in this types.ts file that I showed you. So go back to the ball.ts, we import I think I'm gonna bump up the font size a little bit. So we import curly brackets or vector capital V from / types. So that's the types for the vector, the X and Y. Then we have to export this class as we're going to use it in another file. Export class ball, capital B, like this. And that's enough for now. That's our scaffolding of the class. For now, we're going to come back to this later. Grab this code, copy it, and also save the file. Go inside the brick.ts, and we paste it in the brick class, and we rename it to brick, save it. Then we go inside the paddle, do the same thing, paste it, and change it to paddle, and save it. And now we can use these and import them in our canvas view. So go back to the canvas view class. I'm going to mark this with types. So import brick from / sprites / brick, like this. And then we have two more. Import paddle from / sprites / paddle. And the last one, we're going to import ball from / sprites ball. And you can see here that this is actually the classes that we import here. But when we're in TypeScript, when we create a class, we can also use these ones as a type. So TypeScript will create a type for us when we create a class automatically. So we can both use them as a class and as a type. And in this case, we're going to use them as a type. All right, then we create our CanvasView class. So export class CanvasView, capital C, capital View, like this. And this class is going to have some methods and also some properties. So I want to create these properties as private properties. That's something we have in TypeScript. So only this class can access these properties. So I like to create the properties as private if it's possible, if we don't want to use them outside of this class. And it's always a good idea to isolate everything that you can inside a class if we don't need to use it outside of the class. So we're going to specify some types first for these private properties. It's going to be 5 of them. And when you specify type in a class with TypeScript, you do it up here outside of the constructor. So private canvas. And that one is going to be an HTML canvas element. Yeah, and now it will complain because we haven't actually created this one. So that's why we're going to fix that in a second. We're just typing these ones now. And we type another one, private context. And this one is going to be a canvas rendering context 2D. Or it can also be null. So we have a pipe and null. So that's the type for the context. Then we're going to have a score display, private score display. It's going to be an HTML object element. That is going to be the div where we render out the score. And we have a pipe. It can also be null. Then we have a private start. That's going to be the start button. That's also going to be an HTML object element. And a pipe and null. And we have a private that's called info. That's going to display some information for the player. And that's also going to be an HTML object element or null, like this. So that's our types. Then we can create our constructor that we need for our class. We're going to take in one parameter for this one, and that's the canvas name. So this one is going to be dynamic, and we can specify exactly what canvas we want to use. So that's going to be the name. For example, you can see here in the index.html, I have a name on this that's called playfield. That's the ID. So that's going to be the one that we send in here to make it a little bit dynamic. We have curly brackets, and we can create the stuff inside of our constructor for the class. So we're defining this canvas up here as a private property, and we access this on this.canvas like this. And you can see that now it won't complain because we're creating it in the constructor now. And from the document dot query selector, we're going to grab the div with the canvas name. And that's, of course, this one here. It's going to be a string. And we also want to specify it as an HTML canvas element, like this. So we're telling TypeScript that this one that we grab here from this canvas is going to be an HTML canvas element. And you can see if we hover over this, you can see that the CanvasView.canvas is going to be of the type HTML canvas element. So when you hover over stuff, you can see the type of stuff here. And that's what I did here to find this type. When I created the canvas and I created these variables, I can hover over it, and that this type for the specific canvas is called HTML canvas element. All right. Then we're going to create the context, this context equal. And from this .canvas, we're going to get context. And we want to grab the 2D context like this. And you can see if we hover that this CanvasView.context is going to be of the type canvas rendering context 2D or null. Then we have this .score display. It's going to equal to document query selector. And we're going to grab a div that's called a hash symbol score. And if we look again in the index.html, you can see that I have this div here. So that's what we're grabbing and put in these variables in this class. We have this start. That's going to be the start button that we grab from document query selector, document query selector. And it's called, we have the hash symbol and it's called start. And the last one is going to be this .info equal document .query selector. We have a hash symbol again and it's called info. So that's all of the properties we need for this class. And we initialize them in the constructor here. And with this parameter, we can send in whatever div we want to grab for the canvas. Then we're going to have some methods in this class. So first we want a method to clear the canvas. And we're going to call it clear. This one is not going to return anything. So we specify it as :void because we're returning void. We return nothing. So that's how you specify it in TypeScript. When you have a function that won't return anything, you specify the return type as void. And we have the context. This is the one that we're going to work with the canvas. We have created this context from the canvas. So this .context, and also this can be null. And that's no good because this will complain. And we can tell TypeScript with a question mark like this. So this is called optional chaining. If it can't find this one, it will return undefined for us. So that's very handy to have that question mark. And you can put it anywhere in the chain. You're going to grab your properties and it will return undefined if it can't find it. On the context, we have a method that's called clearRect. Oh, did you see that? I typed in clear React. That's because I work with React. So I have it in my fingers, but it should be clearRect like this. And we specify it at the point 0 and 0. That's the top left. And then we have this canvas.width. We grab the width of the canvas. And we have this .canvas.height. And this is going to clear the complete canvas. And that's what we want to do on every frame that we draw. We're first going to clear everything, and then we're going to draw on new stuff. And you can see if I remove this question mark here, it will complain and tell us that this object is possibly null. And that's no good. So if we use this optional chaining question mark, it will return undefined if it can't find it. So it's very handy. Okay, so that's our clear method. Then we're going to have a method to init our start button, and we call it init start button. And to this method, we can provide a function that will trigger when we click the button. So we're going to call this parameter start function. And our start function also needs to get the view. So we have a parameter view, and that for sure we know is going to be a canvas view. And the canvas view is, of course, this one that we're creating here. So we use this as a type here for this one. And it's going to return void. So we have an arrow function here that we say is going to return void. And also this init start button is going to return void. All right, so what's going on here? Okay, we have this init start button method. This method is going to take in another function that we want to attach to our start button. So we can provide any function we want to our start button. And that function for the start button is going to need the view. So we're going to send in the view. And this is the actual view that we're working on. And also that function is going to return void. And this method that's called initStartButton is also going to return void. So this .start, this can also be null. So we have our optional chaining, our question mark. We're going to add an event listener to this one. We're going to listen for the click event. And then we have our function. We create an inline function because we want to send along this parameter to our start function. And we give it this. This is going to be this class that we're working on in this case. So it's going to be the CanvasView. And we're telling it here that this parameter needs to be of the type CanvasView. And we're telling it here that this needs to be of the type CanvasView. So that's why we can provide the CanvasView to this start function. So that's the initialization of our start button. Then we need something to draw a score. So we have a method called drawScore. It's going to take in the score, and this is going to be a number. It's also going to return void like this. So if this dot score display, because this can also be null. So in this case, we check with an if statement if this dot score display, if we have a score display, we're going to set this dot score display dot inner HTML to the score, and we convert it to a string, like this. So that's how we draw the score to our div that we grab up here, score display. Then we want to draw some information about game over and game start and stuff like that. So we have another method that's called drawInfo. We have the text, it's going to be a string. So that's the text that goes inside of that information div. It also going to return nothing, so we specify the return type to void. If this .info, if we have this info element, this .info.inner HTML is going to equal to the text. And this one is already going to be a string, so we don't have to convert it to a string. So that's the info. Then we need something to draw our sprites. And the sprites is going to be the bricks, ball, or paddle. And we can use this method to draw all of them. So draw sprite. Then we have the brick. And this can be of the type brick. We have a pipe because we want another type. This is how we can specify multiple types. And it can be a paddle. And it can also be a ball. And it's going to return nothing. So we specify the return type to void. And the first thing we're going to do is to check if we have a brick, if exclamation mark brick. If we don't have a brick, we're going to return early. So we return, we do nothing. But if we have a brick, we're going to draw something on the context. So this dot context, we have a question mark, this optional chaining thing again. And we call draw image because these are images that we want to draw on our canvas. And we have a method for that on our canvas object. So draw image. And first we specify the image. So brick.image. So these are properties that we're going to create in the brick class later. We're going to attach an image that's going to be a string. So we're going to attach the image. And we're also going to attach a position, width, and height. So we specify the image. And then we have the brick.pos.x. And we have the brick.pos.y. And we have the brick.width. And we have the brick.height. Like this. And of course, this one doesn't exist yet. So that's why it will complain here. So we will get an error if we try to save this and run this now. I think it will give. No, it actually won't give us an error because we're not using this class yet. These ones are going to be fixed when we create the brick that we're going to send into this function. So all of these ones, brick, paddle, and ball, need to have these properties. Otherwise, this won't work. And you may also wonder, ball, that one is round. Yeah, it is. But we're actually going to have this as a brick also because it's an image with a transparent background. So if we look in the images for the ball, you can see here that it has this transparent background. So it's a round image inside of this square. So that's why I'm going to use it as a brick also. All right. So that's draw sprite. And the last method we're going to have is draw bricks. And this one is going to get an array with all the bricks. So we have the brick. and we specify it as an array. So this is how you type an array. You have the type, and then you create these square brackets just to the right of the type. And this will tell TypeScript that this is going to be an array where each element is going to be a brick. And it's going to return nothing. So we specify the return type to void. So this method is going to receive an array with all the bricks that we want to draw. So the bricks dot for each. For each of these bricks, we're going to loop through them. We have a brick, an inline arrow function, and we call this method here draw sprite. So this dot draw sprite, and we give it a brick. So this is how we can, and of course this one needs to have an S. So this is how it's going to work. We send in all the bricks, we loop through them, and for each brick we're going to draw this sprite on the canvas. And this is everything for our canvas view. It may seem a little bit tricky right now because we haven't seen it in action yet. So that's what we're going to do later. I think it will get more clear when we actually use this class to draw something on the canvas. So next we're going to scaffold out some stuff in the index file, and then we're going to continue on to create our bricks, and we can draw the bricks on the canvas. So we have our canvas view, our little class that makes it possible for us to draw on the canvas that we have in the index.html, this canvas here. So that's great. We have some small little arrows here now, but that one is going to be fixed when we create these properties on the classes here. But first, we're going to scaffold out some stuff in the index.ts file. So move inside of that file. So we remove this here, and we're going to import some stuff first. Import the canvas view from /view canvas view. We need all the sprites, so import ball from /sprites ball, and we import the brick from /sprites brick, and we import the paddle from /sprites, you guessed it, paddle. Then we're going to need some images. So I mark it with images. So I'm going to import paddle underscore image from /images paddle .png. So I have capital letters and underscore on this one. So that is obviously going to be the image for the paddle. And then we import ball underscore image. You can name them to whatever you want. They don't need to be named like this. And this is what's so sweet, and that's why I created this type declaration for the images, so that I can import them like an ES6 module like this. We have /images /ball.png from like this. So that's the images. Then we're going to import some stuff from our setup. We have a lot of stuff here that we need to use inside of the index file. So that's what I'm going to import next. And I'm going to mark it with the level and colors. So import, we have the paddle underscore speed. We have the paddle underscore width. We have the paddle underscore height. The paddle underscore start X. That's where we want the paddle to start on our playfield. Then we have the ball underscore speed, the ball underscore size, the ball underscore start X, and the ball underscore start Y. We're going to import them from /setup. So that's the values from the setup file. We're also going to have a few lets here. So let game over equal false. We set it to false as a default value, and let score, and it's going to have 0 as a default value. Then I'm just going to scaffold out some functions here. Function set game over, and this one is going to take in a view, so view, and we use the canvas view as a type for this one. And inside of this function, we call the view.drawInfo. That's the one that we created here. We have a method that's called drawInfo. So you can see here, I'm going to send in a string, and this function is going to draw something in this div. So back to the index, draw info, game over, maybe an exclamation mark to be extra clear that it's game over. And then we set the game over to false, because later we're going to set this one to true, and we're going to trigger this function later. And then when we have drawn this, we're going to set it back to false so that we can start the game again. And then we have a function that's called setGameWin. It's also going to take in the view and the canvas view. And we have the view draw info game 1. And we set the game over to false on this one also. And as you can see here, this is actually exact the same function. We're just changing this text here. So we could have one function instead where we send in the string that we want to draw. But sometimes it's good to separate out the logic. If we, for example, want to do something else when we win the game or when we lose the game, it can be good to have them in separate functions. So that's why I didn't do it in one function. Then we're going to have a function that's called gameLoop. And this one is going to have some parameters. This is going to be the main game loop that we have, and it needs the view. It's going to be on the type CanvasView. It's going to need the bricks. And this is going to be an array with our bricks. We have a paddle of the type paddle. We have a ball of the type ball. And then later we're also going to add in some collision to this one. We create curly brackets. And actually, I just realized that I created a private up here that's called canvas. This shouldn't actually be private because we need to access the canvas from this game loop. So up here where we declare the type, remove private from canvas. Otherwise, we won't be able to call this one from the game loop. Very important, inside of canvas view, remove private on this one. Then we can go back to the index.ts. So that's our function that's called game loop. Then we have a function that's called start game. It's going to take in the view, and it's going to be of the type canvas view. So just scaffolding them out now, I'm leaving them empty. And down below here, we can start our view. So create a new view. Const view. We have created this class, but it won't work now as we have these little arrows inside of it. New canvas view. And we're going to grab the div that's called playfield. In this case, I haven't stripped out this hash symbol, so it's very important to include this hash symbol. And if we go back inside of the canvas view, you can see that it's the one that we grab here. We send it in here to the class, and then we use this one here. So back to the index. So we create a new view, and then from the view, we're going to run the init start button. And we're going to give it the start game function. So we first create a view, and then we run this method on the view class to initialize the start button. And the start button will get a click handler that will call this start game function when we click on it. And now it probably won't work. I'm actually amazed that it works still because we have these arrows. But yeah, hey, it has something to do with the default settings, the default setup, that it won't break the application. But these ones won't work now. All right, so that's the scaffolding of the index. And we're going to continue on and create our brick class. All right, let's create our brick class. So inside the sprite, we have the brick.ts file. We're already importing the vector, and we are setting up our class here. For this one, we're going to need a private property, private brick image. And this one is going to be an HTML image element. And we're going to create a new image like this. So if I remove this one here, this type, so if we hover over this one, you can see that this one is going to be of the type HTML image element. So you actually don't have to specify it if you don't want to do that, because it will interpret it itself. So we can leave that out. But sometimes it's good to be extra specific. So if we copy this type here, and that's what I meant before also, if you hover over stuff, you can usually see the type that you want, and you can specify it like this to be extra clear. but you don't have to do it in this case, because when we create this image, it will understand that this one is of the type HTML image element. But now at least it's easy to see just by looking at it that it's going to be of this type. So this is the only private property that we need to specify here. I'm going to show you a little trick now. Constructor. We can actually specify the type inside of the constructor when we have parameters to the constructor that we don't need to create something or modify something like this. If we send in something here where we're just going to use that value, we can specify the type inside of here. So private brick width is going to be a number, and private brick height is going to be a number, and private position is going to be a vector, and private brick energy is going to be a number. And then we're also going to send in the image string. That's the path to the image. So it's going to be of the type string. All right, so that's the constructor. And then we have the curly brackets, and we're inside the constructor. So we have created these shortcuts here of creating the types. Instead of setting them up here, private brick width is going to be a type number. We don't have to do that when we're going to use these values and assign them here. We can just set them up like this, and they're going to have the same name. So that's what I'm going to show you here now. For example, the brick width. So we create this property brick width equal brick width. So if we have the same name here, this one will create this private property, and we can assign the value here directly to that. This brick height equal brick height. This dot position is going to equal position. This dot brick energy is going to equal brick energy. And then the last one, that's the one up here that we had to create here because we're creating a new image here, so we can't really use this parameter as it is. So we assign this parameter to this dot brick image dot src. So we create this one up here, and then we set the src to the path of the image. All right, so we have all these private properties, and how do we access them from outside? We can do that with something that's called getters and setters. So I'm going to create some getters for these private properties, and we use the keyword get width. It's going to be of the type number. So when we get the property that's called width, it's going to return this dot brick width for us. And this means that we could do some stuff here. If we, for example, if we want to grab the width from this one, we can do some stuff before we actually grab this private value here. So that's why it's good to have getters. We can do whatever we want inside of here before we actually return the value. And that's the same with a setter. You can do some stuff and then set the value instead of accessing this value directly from outside of the class. So we call this getter, and we can control exactly what we will get back when we call this getter. All right, we're going to do that for the other properties also. Get height. It's going to be of the type number. Return this dot brick height. Get position, get pos. It's going to be of the type vector in this case. Return this dot position. Get image. This one is going to be of the HTML image element type. Return this dot brick image. Right. We have a few more. No, we only have one more. Get energy. It's going to be of the type number. Return this dot brick energy. So that's our getters, and you can see here that's really sweet because we can keep all this private to the class, and we can only access these properties with these getters. Otherwise, another class or another document, another file or another function won't be able to get these values. So So we can control it exactly how we want to receive these values. And we can also set setter. When we want to set the energy, set energy, it's going to take in a number. And it's going to be of the type number. So you can imagine here we can do some stuff also before we set the value if we want to do that. But in our case, we're only going to pass this on. This.brick energy is going to equal to the number. Maybe this one can be called energy instead to make it a little bit more readable and concise. So this is our class. This is our brick class. So it's essentially only properties here that we set with a width, height, and position, the energy, and also the image for the brick. We don't have any methods on this class because they won't do anything. The bricks, they are only just there on the canvas. They can't do anything. They only have the energy that we're going to keep track of on when to remove that brick. So save this file. And next, we're going to create a little helper function that is going to create an array with all our bricks that we have here in the setup and display field where the bricks are. So we have different bricks here, and we're going to create a function that will create a new array for us, strip out all this blank space, and create an array with all these bricks for us. We have created our brick class, and we have to create an array with all the bricks that we can use for our games because we're going to have more than one brick. And inside the canvas view, we can actually remove this for now, the paddle and the ball, and we can add them in later for the draw sprite method. And then these arrows will disappear. So do that and save the file, and we add them in later when we create the ball and the paddle. And now we're going to add a new file here in the src folder, create a new file at the root of the src that we call helpers.ts. We're going to import the brick from ./sprites brick like this. And then we need some values from the setup. So import. We need the brick images. We also need the level. We need the stage underscore calls. We need the stage underscore padding. Whoops. Padding. We need the brick underscore width. We need the brick underscore height. We need the brick underscore padding and the brick underscore energy. And we grab them from ./setup. And of course, these are the ones that we have here that we can import wherever we want to use them. So back to the helpers.ts. And now we're going to create this little function that will create an array with all the bricks for us to use for the game. So we're going to export this function. We call it create bricks. We don't have any parameters to this one. It's going to return an array of bricks. So brick and square brackets. And that will tell TypeScript that it will return an array where each element is going to be a brick. And now you can see that it complains because we're not returning anything now. So this one is obviously going to be fixed when we return something. So if we look in the setup, we have this array here, the level array, where I specify all of the brick types. And now we're going to loop through this array and create another array with all the positions and stuff for the bricks. So inside this function, create bricks in the helpers file, I'm going to return from the level, I'm going to reduce because we're not going to return an array of the same length. We're going to strip out the zeros, for example, where we're not going to draw anything. So that's why I use reduce. If we, for example, map through them, you have to return an array of the same length. So we're going to have the accumulator. We're going to have a cell. And we're going to have the iterator. And the cell is going to be each element in the array. I don't know if it's correct to call it cell, actually. We could call it element instead, maybe, like this. Do as you want. And then I had curly brackets for this arrow function. So inside of here, first I'm going to create a const that I call row. And I'm going to math.floor. I have the I, the current number that we're on. I'm going to add in 1 because it starts at 0. Then I divide it with the stage underscore calls. And this is going to give us the current row that this specific brick is going to be on. And then I'm going to have a const for the column. And I have the I, and I use the modulo on the stage underscore calls. And that is going to give us the correct column for that specific brick. And then we're going to calculate the x and y value for the brick that we're currently on. Const x equal. I'm going to take into consideration the stage underscore padding that we can define also. That's the padding. If we look, we're going to have some padding here on the edges of the stage. So that's what we can specify ourselves, how much this padding is going to be. We want some space between the walls and the bricks. So that's why I have this padding. Then I'm going to add the column times. And I have the brick underscore width. Plus, I also have a padding on the brick. We want some space between the bricks. So brick underscore padding. So that's the x value. And then we have the y value. Yet again, I consider the stage padding. And in this case, I'm going to add the row times. I have the brick underscore height plus the brick underscore padding. Like this. And this is going to give us the correct x and y values, hopefully. And then I check if cell equals 0. We're going to return the accumulator. We don't do anything. So that's how we strip out all the zeros. If we just return the accumulator, we're not creating a new element. So that is why it's stripped out. But if the cell isn't, and yeah, we rename this one actually to element. So it's going to be element instead of cell. And then on each iteration, we're going to return an array. I spread out the accumulator. That will keep the old values. And then I add in a new element to this array. And I create a new brick for that one. And the brick that we created up here in the sprites, you can see that it takes in some parameters here. So we have to specify some arguments. We have the brick width, the height, position, energy, and the image. So that's what we're going to specify here. So we have the brick width first. Then we have the brick height. And then we're going to specify the x and y coordinates, and that's a vector object. So I create an object here. I give it the x and y. It's important to have comma here also between all of these ones. Then we have the brick underscore energy, not height, energy. And we have to grab this specific energy for this brick. And from the brick energy, if we look in the setup, this one is an object, and we know the brick number. So if we're on brick 3, it's going to grab this value. So this is what's called a lookup object, where we can specify the property and it will grab the value. If we give it the element, we know which number that is. So we grab that specific energy for the element. And we can do the same on the brick underscore images. We give it the element like this. And then as this is a reduce, we need to specify a start value for this one. And I'm going to specify it down below here, just before the end parenthesis. It's going to be an array, but it won't be satisfied with that actually, because we have to specify it as a brick array like this, and then it will be satisfied. When we specify it like this, we tell the reduce function that the start array is going to be interpreted as an array with bricks. And this brick images is also a lookup object inside of this setup. So if we have the value 3, for example, from this array here, we know that this is the yellow brick image, and it works the same here on the brick energy. So go back to the helpers, and I'm just going to recap what I did here. So in this create bricks function, I'm going to reduce that level that we have. I'm going to loop through every item with the reduce method. I create a row and a column for the brick that we're currently on. And then I calculate the X and the Y position depending on the row and the column. So we get an X and Y value where we're going to position this brick on the canvas. If this element is 0, we look here, we have all these zeros here. We don't need to do anything with these. So we're going to strip them out. So if it's 0, we return the accumulator and don't put a new element in this array. Otherwise, we create the brick. So I spread out the old accumulator to keep the old values, and then I add in the new value. I create a new brick. I give it the width, height, and the X and Y position, and the energy and the images. So this array is going to be an array with bricks, hopefully. And now if we go back to the index.ts file, we can hopefully draw some bricks on the canvas. And here below this, where we import the setup, I'm going to mark this with helpers. And then I'm going to import create bricks from ./helpers. So we import this function so that we can use it in our code. And down below here, we're already initiating the game. We are setting up the start button, and it's going to run the start game function. And that's this one here. And in this start game function, we're first going to reset the displays when we start the game. We set the score to 0. View.drawInfo. We're going to set it to an empty string to clear that div. And view.drawScore. We're going to give it to 0. We set the score to 0, not only in the variable in the let here, but we also want to show the user a score of 0. So that's why we reset it like this. First in the variable, the let, and then in the view itself. Then we're going to create all bricks with this function that we created now. So I create a new const, bricks equal create bricks. And this is hopefully going to return all the bricks for us. So if we look on the return type here, you can see that the return type is an array of bricks. All right. We're going to call our game loop. And we give it the view and the bricks. And this won't work now because we specify this here that it should have all of these parameters, view, bricks, paddle, and ball. We don't have the paddle and ball. So I'm going to comment these ones out. And now you can see that it won't complain because now we give it the view and we give it the bricks. And inside here, of course, we're going to add this in later when we create the paddle and the ball. So the first thing we do in our game loop is to actually clear the canvas. So view.clear, we have already created this method when we created the canvas view. And then we call the view.drawBricks. And we give it the bricks. So view draw bricks. And then we're going to use request animation frame. So instead of setting an interval, I'm using request animation frame to make sure that we don't do any renders that's unnecessary. And request animation frame requires a function. And we're going to call our game loop again and give it the view and the bricks. So this will keep a loop forever and forever until we break it. Save, reload, press play. And you can see that we have this one here. And now it will keep on looping. But if we go to sources and click pause, that will pause the game loop. We can also console log draw like this to see it in action. So I reload it, go to the console, click start. And you can see that it draws. And if we don't want it to be like this now, we can go to sources here in Chrome and press pause. And that will break it. All right, so that's our bricks. Let's add in the paddle next. So we have our bricks, move back inside of the code. And inside the paddle.ts file, inside of the sprites folder, we're already importing the vector and we're exporting a class that's called paddle. This one is going to have a private paddle image property. And it's going to be of the type HTML image element. and we create a new image, just as before. We have a private move left. It's going to be a Boolean. And we have a private move right. It's also going to be a Boolean. We have a constructor. And we have a few more that I'm setting here. The shortcut that I showed you before. Private speed is going to be a type number. We have a private paddle width. It's going to be of type number. Private paddle height is going to be a type number. And private position is going to be of type vector. And the image is going to be a string. Right. We have curly brackets. And we can create our constructor. So we're going to set this dot speed. It's going to be the speed. This dot paddle width is going to be the paddle width. This dot paddle height is going to be the paddle height. This dot position is going to be the position. This dot move left is going to be set to false as initial value, and this dot move right is also going to be set to false. And this dot paddle image dot src is going to be the image string that we send in with the path to the image. All right, that's all the properties that we need for this one. We're going to do one more thing inside of this constructor, and that is to set up the event listeners on the keyboard. Event listeners like this. So on the document, we add an event listener that's called key down. And we're going to call a method handle key down for this one. We haven't created this one yet, but we're going to do that in a second. And document add event listener key up. And we have a method that we're going to create that is called this dot handle key up, like this. We're going to use the arrow functions, and when we press either the right or the left arrow function, we're going to trigger the key down and the key up when we release it. Then, just as before, we want to access these private values, so we need to have some getters for these ones. Get width, it's going to be a number. Return this dot paddle width. Get height. It's also going to be a type number. Return this dot paddle height. Could also copy them if we want and paste them in, but I like to repeat stuff when I teach code. So get pos, it's going to be a vector. Return this dot position. We have the image, get image. It's going to be an HTML image element. Return this dot paddle image. We're also going to need to retrieve the move left and move right booleans. So get is moving left. It's going to be a boolean. Return this dot move left. And we do the same with the move right. Get is moving right boolean. Return this dot move right. So that's our getters. Then we're going to create our methods. We're going to have 3 of them. We're going to have a method that's called move paddle. We don't have any parameter to this one, and it's going to return nothing. So we set it to void. So this method is going to be used when we want to move or paddle. So if this dot move left, we're going to set this dot pos dot x. So if we move to the left, we're going to subtract something from this value. So minus equals sign this dot speed. So we subtract the speed if we're moving left. If this dot move right, this dot pos dot x It's going to be plus equal sign this dot speed. So we have these booleans and we can check against them to see in which direction we're moving. So if we're moving left, we're going to subtract the speed that we set for this paddle from the x value. And if we're moving right, we're going to add this speed value. So that's how we move left and right. Then we need two more methods. We need the handle key up. And for these ones, I create arrow functions because these ones are going to be called here from these ones. So I have arrow functions, so I won't assign anything to this. So we can use this to grab these booleans, this move left and this move right. If we don't have an arrow function, we have to bind the this value. But we can use arrow functions to make it a little bit simpler for us. So this one is going to take in the event. It's going to be a keyboard event. And it returns nothing, so we set it to void. We have an arrow function, curly brackets, and inside here, if e.code equals arrow left, capital A and capital L. Or we can also check against e.key if that one is equal arrow left. Then we're going to set this dot move left equal to false, because this is the handle key up. So we're going to set the value to false because we're not pressing any key. We're not moving. So this is why I had the arrow function. Otherwise, I won't be able to access this easy as I do now. Then we have the if e.code equal arrow right or double pipe e.key equal arrow right. This dot move right is going to be set to false. Do some auto formatting and it will put it on its own row. Nice. So then we have the handle key down. Handle key down equal. We have the event. We have a keyboard event. Again, we return nothing. So we set it to void. We have an arrow function, curly brackets, and if e.code equal arrow left double pipe, we check against the e.key equal arrow left. This dot move left is going to be set to true because this is the handle key down. So then we're moving. If e.code equal arrow right double pipe e.key equal arrow right. This dot move right is going to be set to true. And you could, of course, also combine these ones into one function if you want to do that. But I like to be specific. It's easier to see this way which will handle the key up and which one which will handle the key down. And this is all there is to it, to this paddle class. So we have this move paddle. It's going to check against these booleans, move left and move right, that we set in the handle key up, handle key down when we press the keys. So if these ones are set to true, we're going to move the paddle. And we can move back to the index.ts file. We're already importing the paddle up here. So we can create a new paddle, and we're going to do that in the start game function. Create a paddle. Const paddle equal new paddle. We're going to give it all these values that we want when we initialize the paddle. So we have the paddle underscore speed that we imported from the setup, and we have the paddle underscore width that we also imported. We have the paddle underscore height. We're going to give it some coordinates to start with, and that is an object. So we set the x to paddle underscore start x. And this paddle is always going to be at the bottom of the screen. So we can set the y value to view.canvas.height minus paddle underscore height. And then I just have a value here because I want some padding here also from the bottom. So I set -5 on this one. Yeah, and we also want to give it some more values here. We want to give it the paddle underscore image. And this is also why I changed this one in the view. This one that was a private first. It shouldn't be private because then we can't access it like I do here now, the view.canvas.height. So that's why. So we have the paddle, and we're going to send in the paddle to the game loop. So we add paddle. This will complain now because we also have to uncomment this one here. Need to have a comma like this. So we have the paddle. Also, we need to add it here because we're calling this game loop all the time here. And we also want to draw our paddle. And we're going to set some constraints on this paddle. We can do that in the paddle class itself also, but I want it to be more dynamic. So that's why I'm going to do that check here. So I mark it with move paddle and check so it won't exit the playfield. So that's what I'm going to check here. We don't want to be able to move outside of the borders. So if I'm going to have parentheses, I'm going to check the paddle dot is moving left. We first check if we're moving. Double ampersands, then we check the paddle dot pos dot x. If that one is greater than 0, we don't want to be able to move outside of the border to the left. So we know that when the paddle has an x position of 0, we're as far as left as we want to go. Then we also want to check some other stuff. So we have double pipes, a new pair of parentheses. I check the paddle is moving right. Double ampersands. If the paddle.pos.x is less than the view canvas.width, you can see that I grabbed that canvas from the view here also. That's also related to that one where we removed the private one. Otherwise, we can't access it here like I do. So we check if the paddle position is less than the canvas width, but that's not enough. We also have to subtract the paddle.width. We check the left border and the right border, curly brackets, and then we're going to call the paddle.movePaddle. That's the method that we created in the paddle. So, of course, we also have to draw this paddle on the canvas. So here, just below the view.drawBricks, view.drawSprite, and we send in the paddle. And now you can see that it complains because we removed this from the canvas view. We're only telling it that it can draw a brick. So we're going to add this one in now. We have a pipe, and we specify it as a paddle. So this is what's so great about TypeScript. It's telling you when you're doing something wrong, and you can correct it. So now we can also send in a paddle to this draw sprite. Save the index. Go back to our game. Click Start. And now we have our paddle, and we can move. You can see that it stops at the edges. So it seems to be working, and I'm so happy with it. But we can't really play something. We need to have a ball also. So that's what we're going to do next. We're going to create the ball. We have our paddle and our bricks. So we're going to create a ball so that we actually can play this game, because now it's of no use for us. So I'm going to break this one. And I'm going to go back to my code editor, and inside the ball.ts file in the sprites folder, we have our ball class. We're going to have a private property that's called speed. It's going to be of the type vector. And we have a private ball image. It's going to be an HTML image element equal new image. Just as before, we have a constructor, and it's going to take in the speed as a parameter. It's going to be of the type number. And we're going to have the image. It's going to be of the type string. And then we have, maybe we can have them at the top. We have a private ball size, number, and a private position. That's going to be of the vector type. Curly brackets. And inside of the constructor, we're going to set this dot ball size. It's going to be the ball size, and this dot position is going to be the position. This dot speed is going to be an object where we set the x value to the speed, and we set the y value to minus speed, and that's because we want the ball initially to go up. So this is what we're doing here. When we subtract from the y value, the ball will go up, 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 up instead of down. So that's what we're setting it to initially. Then we have this dot ball image dot src is going to equal to the image that we send in. So that's the constructor. Then we have some getters for this one. Get with, it's going to be a number. Return this dot ball size. And get height. It's also going to be a number. And this one is also going to return the ball size because it has the same width and height. This dot ball size. And that's because I'm creating this like a square, as I said before. So it's not really a circle that we draw on the canvas. It's a square image. So get pos, it's going to be a vector. Return this dot position. I'm doing this a little bit faster now as we have done this before, so that's why. Get image. It's going to be an HTML image element and return this dot ball image. So that's the getters for this class. Then we have some methods. You can actually mark it with methods. We're going to create a method that's called change y direction. It's going to return nothing, so we set it to void. And this one is going to change this dot speed dot y to minus this dot speed dot y, and that will change the direction on the ball. And then we have another method, change x direction. And return type is going to be void this dot speed dot x. It's going to equal minus this dot speed dot x. So it's nice to have it in its own small little methods like this that we can call when we want to change the direction. And then we're going to have a method that's called move ball. We set the return type to void. And this dot post dot x is going to equal this dot post dot x plus this dot speed dot x. Or we can do it like this instead. Plus equal sign like this. So it's a little bit shorter. This dot post dot y plus equal this dot speed dot y. Like this. Nice and clean. So this is everything we need for the ball class. Let's move back inside of the index.ts file. We're already importing the ball up here. So we have to create a ball first. We can do that before the paddle here, I think. Create a ball. Const ball equal new ball. And we give it the ball underscore speed. We give it the ball underscore size. And we have the vector, the position is going to be an x. It's going to be the ball underscore start x. And the y is going to be ball underscore start y. And then we have the ball underscore image. Okay, the ball size. Did I do a mistake? Gonna go back to the ball class. Yeah, and of course that is because I rearranged them here. So we should, of course, have the speed first. Then we should have the ball size, the position, and the image. So yeah, I couldn't rearrange them as I did there. Then I had to rearrange them also in the index. So move this speed up here and have the two private ones in the middle. Save the file, go back to the index. We have the ball. Then we have the game loop. We're going to send in the ball also. So we add in the ball and we have to change it up here. uncomment this one and add a comma. So that's our ball. And we have to add it in here also, like this. Then we have to draw the ball. So up here, somewhere below the paddle, from the view, we call the draw sprite, and we send in the ball. And now it will complain again because we don't have this type. So we go back to the canvas type and we add in the ball type to the draw sprite method. Save it, go back to the index.ts. So we're drawing the ball here. And then we have to move the ball also. Move ball. Ball.move ball. We call that method that we created. I think that should be it. Go back to our game, reload it. And we have the ball, but you can see that it disappears out in the space because we don't have any collision detection, but at least it's moving, so we can see that. We have to add in some collision, and that's what we're going to do next. Okay, we're going to create a very important thing for this game here. Well, everything is important, I think, but we need to have some collision detection. So that's why we're going to create a class for that one. And I'm going to create this class just in the root here. src, new file that we call collision, capital C.ts. So we need some types for our bricks, paddle, ball, and canvas view. So we import brick from /sprites brick. We import the paddle from /sprites paddle. Then we import the ball from /sprites ball. And the last one is the canvas view. Import canvas view from /view canvas view. And we're going to use these ones as types, and we don't create an instance of the class, so we're using them as types. And as I told you before, when you create a class, TypeScript will interpret the type, so you can use it as a type, or you can use the class as it is, just, yeah, as a regular class. So we export class collision like this. We don't need to have a constructor or anything. This class is just to kind of gather all the colliding methods in one class to give it a little bit of a structure. And then you can easily also swap out this class if you have another class with another collision detections. As long as the interface is the same and the methods are called the same, you can swap it out to whatever you want. So we're going to have three methods in this one. We're going to have one that's called check ball collision. Collision like this. It's going to take in the ball. It's going to be of the type ball. It's going to take in the paddle type, and it needs the view. And it's going to be of the canvas view type. And it's going to return nothing, so we specify it as void. Right? So first, one, check ball collision with paddle. So we have to check when the ball collides with the paddle, and we can do that with a nice little if statement. If we have the ball.position.x plus the ball.width, if that one is greater than the paddle.posx, so that's one thing we have to check. We have double ampersands, and we can have another check here, ball.pos.x. If that one is less than paddle.pos.x plus paddle width. Then we have a third one, ball.pos.y plus ball.height. If that one is equal to the paddle.position.y. And this one is a little special because we're going to create a more generic collision detection function up here in a second. But in this case, we don't actually want the ball to be able to hit the sides of the paddle, because that will create a very strange behavior. So if the Y position is the same and we're outside of the paddle, we're just going to let it fall down and the game will end. So that's why I have this little special one with these 3 different checks here. So if this is true, then from the ball, we're going to change Y position. No, change direction. Change Y direction. Right. That's the first one. Then to check ball collision with walls. So first we check the ball movement X constraints. And how do we do that? Well, we have another if statement. If ball.pos.x, if that one is greater than view.canvas.width minus the ball width, or we have double pipes, the ball.pos.x is lesser than 0. Then from the ball, we're going to call the change X direction, because then we know that we collide with a wall to the left or to the right. So then we change the X direction, and then we also need to check ball movement Y constraints. If ball.pos.y, if that one is lesser than 0, plus ball.height, then we call ball change Y direction. So this is the canvas. The Y value is going to be 0 at the top. So if we leave the play field, then we're going to change the direction. So if we collide with the wall at the top, we don't have to check for the wall at the bottom, because we take care of that when we lose the game and the ball disappears from that wall. So it actually should be able to disappear from that wall. So that's why we don't do it here. So I think we can actually try this one out. So go back to our index.ts file, and up here, we're going to import the collision class, import collision from ./collision. So first in our start game, we have to create the collision. We can do that here. Create the collision instance. Const collision equal new collision. Right. So the only thing more we have to do here is to send it along to our game loop. We do that last collision. And up here in our game loop, we have to take this one into consideration also. So we add this one in, collision. And we use the collision as a type. We also have to add it in here to the request animation frame collision like this. All right, and what do we have to do here in our game loop? Yeah, well, somewhere maybe after we move the ball and paddle from the collision, we can call the check ball collision. We give it the ball, the paddle, and the view. Right, save it, go back to our application. See what happens. We click start. No, it didn't work. And yeah, I can see here now we need to invoke this function also. So that's why. So add this little parenthesis here, save the file, go back to our game, reload it, start, and there you have it. It should work. It looks like it actually collides. Yeah. I don't think we need the ball height on this one, so I'm going to remove that one, go back to the game. Again, reload it, click start. Yeah, so you don't need to add the ball height. And this looks great, I think. We just need to create some little functionality also for colliding with the bricks. So I'm going to break this one, sources, pause, and I go back to my code. And inside the collision class, we're going to create another method that we're going to use for check ball collision with bricks. And we call it is colliding brick. It's going to take in the ball with the ball type, the bricks. It's going to be all the bricks. So it's going to be the type of brick array, an array with bricks. And that's everything we need. It's going to return a Boolean in this case. And if you wonder why I have separated this one out and don't have it in this collision method here, that's because we want to have this Boolean to see if it's true or false. If we're colliding with a brick, we want to add to the score also. So that's why if this is true, we can add to the score. So that's why I lifted it out from that one to have it in its own separate function. Okay, so we're going to send in all the bricks, the array with bricks, and we have the ball. So we're going to loop through these bricks and see if we are colliding with anything. So let colliding, we set this one to false first. Then we're going to run a for each loop on the bricks. If you don't want to use a for each loop, it's a little bit faster to use a regular for loop instead if you want to do that, but I don't think it matters in a small game like this. So we have curly brackets, and inside of this for each loop, we're going to do something. So first, we have to check if we're actually colliding with this brick. So if this dot is colliding bricks. And I'm going to create another function for that instead of having it inside of this one. Maybe this one should be named, I think it's better to actually name them the other way around. So this one is colliding bricks. This one is colliding brick. This one is going to take in a ball and a brick. So up here above this one, we're going to create this one is colliding brick. We have the ball of the type ball. We have the brick of the type brick. If you want, you can add in the paddle and you can use this one, but you will get some strange behavior, as I said, because then we're checking all the edges on the paddle. So yeah, it will probably work in most cases, but that's why I created this little special one down below here instead. So I'm going to remove this for now, or not for now, I'm going to remove it. And it's going to return a Boolean. And this if statement that I'm going to create now, this is actually a famous general little if statement for checking collision between two boxes. And that's also why I have the ball as a box, because you won't be able to see that it's actually colliding a little bit outside of the circle of the ball. So that's why it's actually a square, and we can check the square against the bricks. That's also a square, and that will make it a lot easier to do a collision detection. So we have an if statement. If ball pos.y, no, .x is less than brick.pos.x plus brick.width. That's the first one. Then we have the ball.pos, and also note that I had double ampersands there. We have the ball.pos.x plus ball.width. If that one is greater than the brick.pos.x, we have double ampersands. Then we have the ball.pos.y. If that one is less than brick.pos.y plus brick.height. And the last double ampersand, we check against ball.pos.y plus ball.height. If that one is greater than the brick.pos.y. This will make sure that we check all the sides on the box on both the ball and the brick to see if they collide. And then we return true. Otherwise, we're going to return false. We're not colliding. And that's why I specify the return type as a Boolean. All right, so we can continue on. We check this here. That's why I lifted it out also, so we don't have everything in the same function here. So if this is colliding, first we're going to change the y direction of the ball. So ball.change y direction. Now I make sure to call it also like this with double parentheses. And then we're going to check if the brick.energy, if that one is down to 1, we're going to remove the brick when we collide, because then it's going to be 0, and we're going to remove the brick from the array. So bricks.splice from the index and 1 step forward, we remove that brick. Else brick.energy minus equal 1. We remove 1 from the energy for the brick. And then we have this little let up here colliding. We're going to set that one to true. And then in the end, just below this one here, we're going to return colliding. So we're going to return this variable here. So it's going to be true or false depending on if we collide. So these are the functions that we have. So save this file, and we go back to the index.ts file, and just below where we check the ball collision, maybe this one could have a better name also, because this is actually the ball that we do a collision check on also. But all right, I'm going to let it be. You can rename them to whatever you want. This one I'm going to put in a const is colliding, const colliding. So from the collision class, I'm going to call is colliding bricks with an S, and we give it the ball and the bricks. And we can then use this one because this is going to return true or false. So we can use this one to actually calculate some score also. So if colliding, so if we are colliding, if this one returns true, we can rename this also. If colliding, const colliding brick. That will make it a little bit clearer. If colliding brick, we're going to add 1 to the score plus equal 1. And we also want to render it. So view.draw score. And we give it the score. Save the file. Go back. Reload it just to be sure. Start. And you can see that it's colliding. And these ones have more than 1 in energy, so that's why I have to hit them more than 1 time. And there you can see they disappear because the red and the green only have 1 as energy. These ones, the yellow ones, have 2, I think. So it seems to be working. We have a fully working game, but no, not really fully working. We have to add in that if we lose the game and also if we win the game. And then we'll be finished with this one. All right, I'm going to break it. We have one more thing to do before this game is finished, or at least finished in this tutorial. You can always build on it and make it more beautiful and add functionality to it. And hopefully you've learned some stuff about TypeScript. So let's move back to our code. We're going to create the game over and game one functionality. And for this one, we're going to be in the index.ts file. And just below here, if colliding brick, I'm going to mark this with game over when ball leaves playfield. If ball.pos.y is greater than view.canvas.height. So if the ball is outside of the canvas, we set the game over to true. Then if game one, set game over and display win. So if bricks dot length equals to 0. So this is quite a simple check I do if we have won the game. If we don't have any bricks in the array, if the length is 0, we know that we won the game. So this will stop the game when you hit the last brick. And then we return and also call the set game win. We give it the view. If you remember from the beginning of this tutorial, we have this set game win where we display game one and we set game over to false. And we also have one for game over, for game over here. So this is for game win. Return if game over and don't run the request animation frame. So this is how we break this infinity loop, or it's not actually infinitive because we can't break it, but it will continue on if nothing else happens. So if we win, as we return here, it's not going to run this one here. And that's how we also do when we lose the game. And we check if game over, if that one is true, we're going to return. And we also call the set game over like this. We have to give it a view also. And this should be it. Hopefully we have a fully working game now, I think. I'm going to save it and try it out. So I reload it. I start it. See what happens. Yeah, it says game over. I'm actually going to play it through now, and I'm going to skip here a little bit and come back to you. Yeah, and there you have it. You can see that that I won the game now, and it freezes here on this image. So if you don't want that, you can do something else when you have won the game and clear the playfield and stuff like that. But at least it works. Hopefully this gave an idea on how to create a game like this with TypeScript. And I hope that you learned a lot about TypeScript also. And as usual, if you like my stuff, make sure to subscribe on my channel and tell the world about my great tutorials. And hopefully I see you in another one.